Okay, great. Thanks for the good introduction, Ryan, and welcome everyone for joining us today. So we'll get started. We're actually going to be talking about a lot of technology that's inside of our recorders and what they do and how they work. So this is something we've been working on probably for close to 15 years at least, developing new techniques and always trying to get more performance, faster operation, wider bandwidth signals, more storage capacity, and new form factors. So we're gonna kind of first of all look at who needs these recorders, and the recorders can be used in all of these fields that you see here listed here on the left. It really cuts across a wide range of intelligence gathering, war fighting, testing, antenna design, countermeasures, as well as a lot of recorder missions where a recorder is sent into an aircraft or a vehicle of some time to capture very useful information, bring it back so it can be analyzed, dissected, and then someone can make decisions and act upon the information that's gleaned. So there's a huge group of people who are using it, and these are just some of the titles of those who do so. Just to give you a quick overview of things we're going to be talking about today. What we mean by real time, we mean a recorder that captures every single sample, guaranteed. It's not that you're going to have gaps. You need a continuous guaranteed recording. We're currently recording at sustained rates up to 12.5 gigabytes per second. We can handle up to 256 terabytes of storage, so that's hours even at gigahertz rates. It's a complete instrument that we're offering. You don't have to do software development. The files that we record are stored in NTFS format so that you can open them up with Windows applications like MATLAB, for example. We have analog front ends that digitize wideband RF and IF signals, and we also have digital front ends like serial FPDP, LVDS, and gigabit Ethernet. We also can play back signals that we capture. Once they're recorded, we can send them back out through a D-to-A converter to create RF waveforms and reproduce those RF signals back in the lab or even out in the field. We can do multi-channel synchronous phase coherent signal acquisition. This is really important for phased array antennas where you're doing beamforming, direction finding, and also you can use it for capturing radar signals in an array antenna configuration. We have time stamping of GPS and iRig. We have real-time signal viewing and analysis, so you can look at the signals you're acquiring both during and before and after you capture them. We now have a new resource we'll talk about that allows you to do custom DSP processing of the signals that you're capturing before they get recorded. An application programming interface allows customers to create interfaces to our systems from remote locations, and we have a wide range of different form factors and enclosures for a lot of different application spaces. So that's a lot of topics, and we're going to touch on those right now. But I thought first of all we just review what the heck is inside of a wideband RF recorder. Typically, what will happen, you start out with an antenna frequency RF signal coming from an antenna. Before that gets used to drive an A to D converter, however, it has to be amplified. It has to be filtered and often frequency down converted to create an analog IF signal that is large enough in power to drive the A to D converter. The A to D converter will then create digital IF samples from that analog input. Those digital samples are then sent into a digital down converter that uses a digital local oscillator, a digital mixer, and a digital low-pass filter to move that IF signal, which is centered at a certain IF frequency, down to DC or down to centered at 0 hertz to produce digital complex baseband samples. We then send those baseband samples into a storage, a disk array. Could be a RAID array typically. And that could be either hard drives or solid state drives. So this is a kind of an overall simplification of the blocks of different stages of signal processing as you go from the antenna to the point where you get to the disk. Now, doing all this requires quite a bit of coordination with the hardware and the software. So the software we use is called SystemFlow. And just to give you an idea of what it does very quickly here, most of our recorders are based on high-performance Windows PC platforms. So here is a representation of a front-end module which contains an A to D converter. Here we're not showing the RF tuner at the front end. We're just assuming that we have the signal ready for connection to an analog to digital converter or a D to A converter. And then we have in our PC, we have system memory, where we use circular buffers to buffer the data that's coming from the front-end module. And then a RAID controller, which also aggregates the speed and the capacity of the multiple disks that are connected to it. So you can get very high recording rates based on, aggregating those speeds of each of the disks that are connected. Now, how are these connected? They're connected typically on a motherboard or equivalent, which has PCI Express links that join up all the different elements in the motherboard for very high-speed transfers between the module, like the A to D module and system memory, and then from system memory to the RAID controller. Controlling those transfers of data is the operating system and the software, the system software, which actually initializes the I/O modules. It sets up the DMA, that's the direct memory access engines that are part of the I/O module and part of the RAID controller, to direct it to send data, streaming data, into a certain block of memory in a circular buffer, and then to fetch data for the RAID controller from that block and send it out to the RAID controller for then allocation, striping across the different disk arrays that are connected to the RAID controller. The important thing here is that all of this data movement is done with hardware manipulation. That is, the DMA hardware engines and the PCI Express bus are what we count on for the real-time high-speed rates. The important thing is, by managing just the performance with the operating system and the software, we don't touch the data. The data is not touched by the operating system, and so any kind of latency or non-deterministic operation in the operating system really doesn't affect the real-time recording. The real-time recording is carried out by the real-time hardware that's in the system, as you see across PCI Express. Part of the software includes front panel screens that allow you to configure the operation, the bandwidth, the sampling rates, the number of channels for recording and for playback. These are very easy to use screens for setting up all the parameters. And then we have the API, the application programming interface, that allows you to issue the same kinds of commands that you would do in that GUI that we just looked at, but again, through high-level commands that allows a designer of a system designer to build a software entity that then control our recorders. And this is very commonly used in deployed systems, for example, in aircraft, where you have perhaps a cockpit computer aboard the aircraft. You have a recorder that's sitting in an equipment bay or in a wing, for example, and one of the access panels of the aircraft connected via Ethernet to the cockpit computer, and the whole operation of the computer then dictates the operation of the recorder. So it makes a really nice extensible system, depending on how your system layout looks physically, to have that control take place wherever it needs to. We also provide a very useful signal viewer that gives you a time and frequency display of the signal that you are about to capture, or a signal that is in the process of being captured, or after you get done with the recording, you can play the recording through this signal viewer to actually see what was captured. This is really useful to make sure you've got wires connected correctly, cables connected correctly, the clock is present, everything that you need to make sure that this recording is actually meaningful and you've got something to record. So it's a really nice, handy tool for validating your recording. Some of the features that we've added to the recorders were driven by customers. And those customers say, I need this, I need that. What we try to do is make these requests standard features for all customers, and we'll often add special features at no cost or very little NRE. And here's just an example of some of the things that our customers have asked for and which we have added. We provide a GPS resource in most of our recorder functions that can retrieve the GPS latitude, longitude, and altitude, as well as the timestamp. And so if you're flying, let's say, in an aircraft or an airborne or a UAV, you're capturing signals from the ground, let's say, but now you want to also know exactly where you were when you acquired those signals. So it's very useful for a moving recorder to have the timestamp, and you can set programmable intervals between the timestamps. And what you then get is a log of each of the different parameters. Here we're spacing these at about, I think this is about a 10-second interval. So every 10 seconds we record the latitude, longitude, altitude, time, and then record that in a parallel file for linking it directly to the recording itself. Another useful feature is what we call alarm clock recording, which allows you to start the recording at a preset time. This is very useful when you have recorders located at geographically different locations where you may want to capture signals, let's say from a satellite, on two different locations, and then by triangulation or using the signals in a diversity receiver where you're combining the signals received for enhanced dynamic range, you can do that synchronously through GPS timing. Another really nice feature is the looping or the continuous feature, where you can, like a kind of a surveillance camera, you can continuously record long periods of time, and when the disk becomes full, the old data is simply overwritten by new data. When a trigger occurs, you can use that to start a period of recording after the trigger and then halt. And this allows you to capture the data before the trigger, be capturing the data at the exact time of the trigger, and then continue to capture data after the trigger. So you have a complete before and after capture of the data, and that gives you often much better analysis. We have a lot of different types of applications, analog inputs, digital inputs. They are deployed in different kinds of vehicles, in the laboratory, in the field. We have a lot of different form factors available, and we're going to look at some of these now. As I said in the beginning, there's a lot of different reasons that why customers find these recorders extremely useful, either as test equipment or as part of the deployed mission recording function. So typical recorders we'll find are capturing radar, SIGINT, Comet, ELINT on all these different platforms. And each of those different environments has its own environmental challenges. And so we have to provide not only different shapes and sizes and weights, but also different environmental qualifications for the different recorders. So we've divided up the recorder family into some groups or classes or series, which we call them. The RTS series is for commercial products. Excuse me. And it features magnetic drives, hard disk drives, and you can get the largest storage capacity because you have space for these large drives, typically 3.5-inch drives, but you could also use smaller ones. But the 3.5-inch drives gives you the highest capacities. These are great for laboratory and office environments, benign environments, and they're typically in a 19-inch rack mount chassis, as you see here. We also have rugged portable recorders. Now we have the RTR, which stands for Rugged Series. And here, you can have quite a nice portable, carryable, suitcase-style recorder that weighs less than 25 pounds. You can get up to 122 terabytes. And even in this small package, you can record at rates up to 4 gigabytes per second, which is really, really quite respectable. And it really makes it easy for you to carry this portable device on an aircraft, for example, or on board a vehicle, or even out in the field if you want to do some field recordings or tests. We then also have rugged series that are rack mount that then can be used for mounting in equipment bays in a deployed environment, like an aircraft cabin, for example. Here you can also get some large storage capacity and very high rates, up to 12.5 gigabytes per second. But here, what you're using is solid state drives, because those drives are quite immune to the effects of vibration, which is a critical factor and a problem for magnetic rotating drives. We also have a small form factor rugged version or rugged series, again in the RTR family. These are removable hot swap solid state drives, up to 61 terabytes of storage. And these will work in moderate environments of shock, temperature, and vibration. They're great for pressurized aircraft cabins and vehicles, and it's still a relatively small size and form factor, much smaller than a rack mount, for example. And then at the extreme end, we have our RTX Extreme Rugged Series, which is fully tested to mil standard 810 and 461. We have removable drive packs that allow you to remove a pack of drives that are inside a little cassette, so that you can take out a full set and replace it very quickly with another cassette that contains empty drives ready to capture more data. These are sealed from the environment. They're really optimized for size, weight, and power. 18 pounds weight, half ATR chassis. And this is really great for aircraft, UAVs, military vehicles, and ships. And of course, with the API, you can run this in a remote application, a remote space, using that Ethernet connection. Now, this is a chart. I'm not going to go through all of it, but this shows you the different series in columns here that we went through, and highlights the major characteristics of each in terms of size, weight, power, temperature, altitude, recording time, and other environmental factors. And the parts that are in yellow are the parts that kind of make that particular series stand out, that kind of characterizes it. So those are the kind of the critical parts of each of those little families that you see here that really make them work, for particular requirements and applications. So I'll let you have that, of course. And then here is another chart, which I'm not going to go through in detail, that just shows you the signal acquisition bandwidth across the top here. These are the columns. And this shows you the sampling rates of the A to D converters. And then down on the left side, you'll see the different families in increasing levels of ruggedization as you go from top to bottom. And then the numbers in there are the model numbers, Pentec model numbers. We have the same thing for digital recorders. Again, across the columns here from left to right, you have the different digital interfaces that are available, different speeds of Ethernet, and then the ruggedization levels going from top to bottom in an increasing fashion. Another really nice feature that we've come out with has been the Sentinel intelligent recorders. And here, what we've done is we've taken a typical TALON recorder and we've added a RF down conversion front end to it and combined them so that the software that runs the recorder is unified with the software that runs the tuner, the RF tuner at the front end. So the user just simply has to enter a frequency, and all of our software will orchestrate the recorder and the tuner to make it appear as one product, one complete product. And this really gives you a complete tested solution from RF, an antenna input, to the disk. So we use a lot of different RF down converters. Some of them are our own, and some are third-party down converters, depending on what the frequency is, what the size. Some are small, some are large, some are instruments. But they do have quite a range of different frequencies and bandwidths. We also do have front ends that are transmitters. So when we play back a recorded signal and generate an IF analog signal from playback, it can then go to an RF up converter, which would be the inverse function of the RF tuner, to bring the signal up to the antenna frequency. And then typically you would go into a power amplifier if you wish to transmit the antenna. But a lot of customers will use this for testing, maybe in the laboratory, in which case, after you come out of the RF up converter, you've got your RF signal frequency ready to, say, stimulate a receiver that you're testing, for example. So the other nice part of the Sentinel is the fact that it's intelligent. So two major things. One is that RF tuner and up converter and as a front end and back end. But the other thing that we provide is enhanced software that take advantage of that RF tuner to do a scanning function and do an automatic detection of signal energy during the scan. So let's say you've got a 26 gigahertz tuner at the front end, and you want to scan across to see if there's any energy. Well, you can set up the threshold so that the energy level exceeds that threshold. What happens is the signal gets detected, the recorder will stop scanning, and it will park itself tuner-wise on the signal where the energy threshold was exceeded, and it will start recording that slice of the spectrum that contains the signal of interest. You can see that over in the right side of that lower figure, where you're actually looking at that RF signal that the scanner and the software automatically detected. And that can continue until the signal goes away, or it can continue for a certain period of time. There's a lot of controls that you have. So here's a list of the products that we have available. These are some tuners that we use at the front end. These are all fully integrated. It shows you the RF scanning range. It shows you the bandwidth, the instantaneous bandwidth of the signal that we capture, and then the different form factors that are available. We've got a couple of new products in development for scanning across a 40 gigahertz range and for recording bandwidths of up to 1 gigahertz. So this is really quite respectable. These will be coming out during 2021. We're constantly adding and developing. Another new recorder is a digital recorder for recording 100 gigabit Ethernet that comes from our Pentec Quartz radio frequency system on chip, or RFSOC product line. And these RFSOC devices generate so much data we had to come up with a recorder that could capture that data at the full 100 gigabit Ethernet rate, which gives you a 12.5 gigabyte per second on each of those 100 gigabit Ethernet interfaces of the RFSOC product, and record onto disk. So these recorders, these boxes, each take one 100 gigabit Ethernet link and can record up to 4 terabytes of storage. These are rugged industrial grade chassis. And the way it works is, here's an example of a small form factor RFSOC enclosure. This is our model 6350. And you can see the one of the center of the one right in the middle, that circular connector, contains 100 gigabit Ethernet. Here's a block diagram of what it has. It has 2 100 gigabit Ethernet ports. The first one containing channel 1 through 4 data, analog channel 1 through 4, and the second delivering channels 5 through 8. So each of these 100 gigabit Ethernet ports delivers 12.5 gigabytes per second, and one RTR 2757 will capture that full bandwidth coming out. Now, if you want to capture the other 4 channels, you simply add another recorder to its output, to the second channel output, and now you can capture all 8 channels of the RFSOC chip at a total aggregate rate of 25 gigabytes per second. That's quite a lot of data. So, and this works extremely well. Another new recorder, which we're introducing just recently, actually we just introduced it recently, is a 6 gigasample per second single channel or a dual channel 3 gigasample per second A to D converter front end that can record signal bandwidths up to 2.4 gigahertz in bandwidth. It contains integrated digital down converters, so you can do digital tuning within that 2.4 gigahertz span. And it also has 2 6.4 gigasample per second D-to-A converters for waveform generation or playback with signal bandwidths up to 1.2 gigahertz, the bandwidth of 1.2 gigahertz, with integrated digital up converters. There's 122 terabytes, front panel removable solid state storage, all in a 19-inch rack. And of course, it comes with the graphical user interface and signal viewer, as all our recorders do. Another new thing that we've been asked for a long time is we don't just want, a customer will say, we don't want to just record the signals. We also want to be able to do some signal processing on those signals. So what we want to do is we want to take the data that comes from your digital down converter, let's say, and what we want to do instead is we want to do some processing. You've got an FPGA on your A to D converter cards and your D to A converter cards. We want to use that FPGA to do something useful, maybe energy detection, maybe demodulation, maybe decoding, maybe pattern recognition in a custom DSP algorithm before it goes on to the disk array. So how do you do that? Well, it's tough. Our TALON SystemFlow is really a critical combination of DMA engines and memory buffers of different sizes and quantities that it is always optimized for specific characteristics of each recorder in order to get the maximum performance. And the IP inside the FPGA is also critical for all of our acquisition engines, pipelines, and interrupts that need to take place as part of the real-time recording overall operation that's required. If a customer changes the SystemFlow software or changes the IP in the FPGA, he can quite easily destroy the real-time operation or degrade the speed of the recorder. So we spent years developing a method to isolate certain regions of the software and the IP and the FPGA, and to protect to protected regions that a customer can actually work in without disrupting the real-time performance of the recorder. And it took a lot of work, and we've started delivering these in the last quarter. It's called Architect, and what it is, it's a combination between our TALON recorder product line that we've been looking at and our Navigator FPGA design kit, which supports all the FPGA development of our hundreds of different software radio products that we make at Pentec. So what it does is it gives you a complete environment for adding custom IP to our TALON recorders. It includes examples with the API, custom FPGA examples, and Navigator board support package examples to make sure you know exactly how you can do it and the safe method of adding it. And it does require the design tools for the Xilinx Vivado design suite for the FPGA compilers. And it also requires, of course, our Navigator packages for FPGA design kit and board support package. But it's really done a lot for customers who have been wanting to do this but have been unable to do so until now. So just a kind of a summary here. The TALON recorders are really complete Windows workstation platforms. They support Windows signal analysis and processing tools like MATLAB, for example. And remember, the files that we capture are immediately available for use by MATLAB right after they're captured. Other vendors will have a proprietary recording format that needs to be converted in a post-processing algorithm to change it to NTFS. But our files are all immediately and natively stored in NTFS as the recording occurs. So there is no post-processing. We've got a lot of different form factors that you've seen: the lab, the portable, rugged, and so forth. And we really offer complete support for a lot of different capabilities. In other words, with analog and digital, everything is highly programmable with bandwidth, tuning frequencies, even the scanning we talked about. These products are ready to use. You don't need to do any software development. They're instruments that are ready to be used. You've got a lot of visibility in the signals that are being recorded with that signal viewer. Got the API to do the remote control. We support multi-channel synchronization of the recording, which is essential for any beamforming or phased array antenna work. And then we've got our Architect custom FPGA development capability that we've just added recently. So this is kind of a summary of all the highlights, if you want, of our TALON systems. If you'd like to get more information about our recorders, you can go to our website and click on the recorders tab. You see there in the top banner, right after products, we have recorders. And then within the recorder section, you've got all kinds of resources about the RF recorders, the digital recorders, SystemFlow, the intelligence scanning, the Architect. It's all really right there. And a lot of, there's a nice white paper too that describes a little bit about more detail of what we were talking about today, is how does it work. Another nice resource is our recorder selector. We have one for the analog products and one for the digital recorders. What it does is it's a pull-down screen of different parameters that you can select simply by clicking on them. And each time you make a selection, the list of recorders starts shrinking to a short list, and each one of these then narrows the list of products to the one that finally looks the best to you. Once you get to a product that you'd like to learn more of, you simply click on it, and it takes you to a complete product information page with data sheets, documentation, and so forth. So it makes it really easy for you to select what you're looking for among the hundreds of different products that we have. You also can look at our specification matrix to help you find things. We've got a handbook, high-speed recording handbook for theory of operation, videos, FAQs. We have a simulator that you can run on your desktop to simulate the look and feel of a TALON recorder. So you get a chance to see how the SystemFlow control panel looks. We have a quote request and a questionnaire where we ask you to answer some questions, and we can get back to you with a quotation, white papers, data sheets, operating manuals, the recorder selector tool I just looked at, and we can also provide demonstration systems as required. So it's really a very, very complete resource for you to get a lot of different very useful information. So I think at this time, that's the end of the formal presentation. I certainly would be glad to answer any questions. And I guess what I'll do is I'll turn it back over to Ryan. Do we have any questions, Ryan?
Thank you, Roger. Yes, we are open for Q&A. Everyone, feel free to use the chat box or the Q&A module inside of the webinar, and we'll stick around and answer some questions for a while here. And just a reminder, I did upload the presentation that Roger just went through into the handouts inside of the webinar, so you should be able to get that, as well as the VMA line card for our embedded solutions, and also included the TALON family overview document in there as well. So a couple downloads in the webinar for you. Questions, Roger, to get us started. You mentioned a lot of data. So with that comes storage. What kind of storage are you guys using? Is it all SSDs now?
Yeah, we migrated, I guess it was about maybe 5 to 8 years ago. We kind of migrated away from the magnetic drives and went to the SSD drives because they really are now getting price-wise extremely competitive. And of course, they offer that protection against vibration and susceptibility to that kind of effect, as they're smaller, and so it's just naturally we're migrating pretty much, except for the very benign environment laboratory, the RTS. You can still get the magnetic drives where the storage capacity is somewhat cheaper. We're also looking at some of the new NVMe drives in the M2 form factor. One thing about those is they're not as easy to remove for the hot swap capability that we like to offer in many of our products. So we're still using, for the most part, we're using SSD form factor, the 2.5-inch SSD, and that seems to be kind of a good balance because it gives us that hot swappability. We can remove drives, and it also gives us a good storage capacity for relatively small space and relatively economical as well.
Yeah, you mentioned a good point there, and maybe you can answer this question. You alluded to it. Can you really hot swap SSDs to replace full ones without losing any data?
Yes, you can. And in some devices, you'll notice that each of the drives, the one that's actually on the screen there down in the kind of the lower left, shows 16 SSDs or even magnetic drives. And what you can do is you can have a RAID controller containing, let's say, 8 drives and another RAID controller containing another 8 drives. Well, you could set up the recording so that that first group of 8 is going active for the recording. When those drives fill up, you can automatically swap over to the other RAID controller to continue the recording without losing any data. And then you can remove the first 8, which are idle at this point, replace them with empty drives, and then swap back to those drives when the current set of 8 are going on. So it definitely does work. The software helps you do that if you need to do that for extremely long missions, for example.
Okay, fantastic. So what's the limiting factor in the recording speed then?
Well, it changes, and as we've gone through development, sometimes it will be the motherboard chipset, for example, that just doesn't have the right bandwidth for a particular link between a slot in the motherboard and the processor or the memory. In other cases, it will be the PCI Express Gen 3 or even Gen 4 interface on a particular data converter module, A to D converter, D to A converter. In other cases, it could be a limitation of the RAID controller. So it really depends a little bit on which configuration you're talking about. The thing that we really try to do is, as soon as you get up to a certain speed, you say, okay, what's limiting me now? And then you go and attack the weakest link and try to achieve that. I think, we're now up to 12.8 or 12.5 gigabytes per second in our 100 gigabit Ethernet recorder. And that took a lot of balancing, not just of the hardware, but also of the software and the interrupts and the buffers and so forth to make that all work extremely well. And a pretty powerful dual Xeon core CPU with a powerful chipset to get that all working at that speed.
Okay, very good. What about zeroization?
We do have some customers who do require, and what zeroization is it's a very quick, secure erase of all the data on the disks. And there are some options that we can add and have added for certain customers where the zeroize function is kind of built into the RAID controller that will then allow you to make safe a recorder that, for example, is possibly going to fall into enemy hands. And let's say it's on a UAV, you want to be able to do that remotely, perhaps with a radio link or under some other predetermined condition of hazard. Just have those SSDs or storage devices wiped clean. It's a kind of a specialty. Another specialty we have is AES 256 encryption, which is another thing that some customers will want, and we do have some options for doing that as well.
Okay, fantastic. Last question I have here is Pentec CMMC certified?
We are working on that. We know that this is coming up increasingly more important and will be required. We're going to be we're selecting right now a consultant to help us with that, to make sure we do it right and do it efficiently and get that on board during 2021 for sure, and as early as possible, because it is important to our industry. Just about everybody's going to be affected by it.
Okay, fantastic. Well, I don't see any other questions coming in here. I am happy to hang out for a moment or two as folks kind of wrap up. We are grateful for everyone signing in here, and as well grateful to you, Roger, for taking the time to do this. As usual, very thorough, very complete. Pentec has a ton of resources on these recorders and all the parts and pieces and software that will really make life easier for the users. So thanks for sharing all that. We will send out the recording to all attendees and those who registered and perhaps did not make it today. So this webcast will be available on demand, and you can always reach out to us at Vic Myers at sales@vicmyers.com, and we'd be happy to help. So with that, Roger, I think I don't see any other additional questions coming in. I think we can sign off.
Okay, I just wanted to say, a lot of customers don't know exactly, the best way to tackle their recording problem. Give us a call, because we have sales engineers that understand how these things work, and we can help you find just the right product that will do the best job for you and weigh some trade-offs, this versus that. We're really experts in this now, and I'm sure we can help you find the best solution. So, and really just thank you everybody today for joining. I hope you found it useful, and look forward to speaking with you again soon.